All right, here we go. So, your stuff yesterday was like this. You were supposed to be able to sketch this. So what could you know from this? You could know the y-intercept, but it's not really obvious. But you have to know how to answer this question. The y-intercept is where what? Where x equals 0. So I can put in a 0 here, and then multiply it all out. And I'd have negative 3 times negative 2 squared times 5. And what has to be first? That has to be first. So that's going to be 4. 4 times negative 3 makes negative 12. Negative 12 times 5 makes negative some really big number. What is it? 60. Thank you. So negative 60 has to go through that. Now, did you have to have that accurate? In the directions, it would tell you. A lot of times on the test, it'll say, here are the things you need to have accurate. The y-intercept is usually one of them. And usually we don't make it as big as negative 60, but hey, if you don't have to label your scale anyway, it doesn't matter that much. I mean, as long as your graph, kind of goes through that point stuff, you'll be fine. All right, so now, could that possibly be the right answer? No, not even close. Some other things you're supposed to know by now. You're supposed to know that this negative in front means that the right-hand side has to end going where? Down. So it has to be going down over here. Another thing I know is that it's going to go through 2, and what spot for that? Negative 5. It's going to go through 2 and negative 5. I know scale-wise that's kind of ridiculous, but anyway, so this basically should be way further down, but it's hard to do that on the board because I can't make it go that much farther down. Anyway, I'm going to make it bounce at 2 because of that. So it has to bounce at 2. So I'm assuming it's probably going to go like this, and a lot of times you'll sketch these and then realize, wait a minute, that didn't work, but I'm going to try this and see, could this possibly be the right answer? All right, so what do I check? I check the x-intercepts, negative 5 and 2, and yeah, those match up from here and there. Next, I would check the y-intercept, negative 60, maybe double check it if it was a test, make sure that's such a big number, I'd double check that one, but we're right. And then last, I'd check for, it's going up and down. Does that make sense for an odd degree of 3? Yes, and the next thing I might check is turns. How many turns do I have? 2 turns, as in it turned once here, and then on the way down it turned again there, 2 turns. And you always add 1 to that, and that should be about what your degree is, degree 3. Could this possibly, well, after they give you the equation, it can't be a degree 5. It is a degree 3, because I can see the equation. But what if instead I gave you the picture? Then you can't know for sure what degree it is, but you can take a best guess. If you had to look at this one, what's your best guess on what degree it is? Degree 4. And that is a couple of reasons why. It's going up on both ends, so it has to be what? Even. And then it has a bounce and 2 cut-throughs. Do you recognize that? Okay, so that's degree 4 probably. Why do I say probably? Because it could be degree what? 6 or maybe 8 if there's what kind of roots? Not invisible. Imaginary. If there's imaginary roots, you can't see them, and so yes, they are invisible, but we call them imaginary roots. Yes?
Why is it so like that's a degree 4 or whatever?
Yep, 4 or 6 or 8, yep.
Yeah, why? So, there's like 3 turns.
Okay, I know it seems like it should be degree 4, but there can be things you can't see. Let me give you another one. If I graphed x to the 4th, do you remember that x to the 4th looks like that? How many turns does it have? So it seems like it should be degree 2, but it's not. It's degree 4. Remember how I was saying sometimes it's more than what you can see?
It looks like you did that last one, there was like...
I know, but let's go. This is my example. It's so simple that you're not going to be able to refute.
No, I didn't.
That is x to the 4th, but it looks like there's only 1 turn. Should be degree 2, but it could be degree 4. All right, so you go back to this one. Bounce and 2 cut-throughs. Seems like it should be degree 4, but could there be something more we don't know about it? Yeah. It's a 4, or it could be a 6 or an 8. Because those imaginary roots you can't see and you don't know for sure. Okay, moving on. A lot of today is review, thankfully. One of the words that they throw in now is multiplicity. And that's just a word for something we already know. If I say there's 3 roots here, okay, is there 3 roots here? Yeah. There's 2 for this one, and there's 1 for that one. And just to clarify, This here is not a root because there's no x on it. Okay, so this one does have 3 roots. This 2 is called the multiplicity of this root. This 1 is called the multiplicity of that root. Okay, so the -5 has a multiplicity of what? 1. And the 2, this root right here, the 2 has a multiplicity of what? 2. All right? If you add up the multiplicities, what do you get? 3, which in this case is the degree of this polynomial. All right, how about this one? This one often confuses people because it's got an x out front. What's the degree of that guy? 5. Because this one gets its own, if you want to put parentheses around it, might make it more obvious. It has its own little degree, degree 1. Okay? So does this have an answer now? Yes, it does. If it has an x there, it has an answer. If this had just been a 3 or something, then it would not. Okay, then I'd just say the degree was degree 4. Okay. All right, next topic. If you were supposed to find the zeros of the function graphically, that means we're going to give you a nasty graph. We're not going to give you a nice one. You're going to type it into your calculator, and it'll be like some weird thing like this, and there'll be weird decimal answers. But where are the roots found? They're these guys. That's a root, that's a root, that's a root, and that's a root. And so you need to know how to get those from typing it into your calculator. Okay, so grab your graphing calculator. Let me show you how to do this. It is as simple as second calculate the 0, but you're going to want to do one with me to make sure you understand it. If you're going to borrow one of mine, leave me a shoe or a cell phone or keys, something of value. All right, so I'd like to graph one with you. We're going to actually do one of the ones from your homework, and so you're going to want to take decent notes on this one because it's problem 9 from your homework. But if I hand the worksheet out, some of you will go work on problem 1, 2, 3, and 4 while I'm showing you how to do number 9. So I'll hand it out in a minute. Number 9's problem says find the zeros graphically, and then you want to graph this. F of x, of course, is the same as y, so you're going to your y equal screen. And you're going to type in x to the third plus 2x squared minus 109x minus 110. Obviously not one we'd have you do by hand, but it would be the kind you'd have to do graphically. I'm going to pause for a second while I pull it up on the calculator. I can just barely see where this thing crosses because of where my window is. Do you get the standard window only goes 10 in every direction? And you guys want to be able to go further than that to be able to see this. So I'm going to zoom out. I'm just going to do a simple zoom out, like enter. And remember, if you don't hit enter again, it won't actually zoom out. Okay. So now I've zoomed out far enough to see, oh, okay, now all of a sudden, it's really, I don't need to be so far out x-wise. My x's, I only need to go a lot less than they are. And that'll help me see it. But I need to go higher on my y's. So I'm going to go into my window. And I'm going to say my x's, that doesn't need to go that far. You're not even close. So let's go like negative 20 to positive 20. And then I'm going to say on my y's, I need to go higher. So like maybe negative 300 to positive 300. And now, let me see if I can see it yet. When I hit graph, not quite. I still can't see the tops of it. But you know what? Do I even really need the tops to find the x-intercepts? Nope. So I'm good enough. Remember, what I want here is these spots. There, there, and there. So now how do you do this again? You go second, calculate. Second, calc. And which of these do I want? The 0. You want the zeros. So you go enter. Now, the left boundary remember, these are my 3 zeros. They're also known as roots or x-intercepts. I'm going to get to the one on the left. So I'm going to arrow over and get to be to this one on the left side. There it is. Okay, now, to get to the left of that spot means to really be under it in this case. I know it's under it, but it's also to the left of it. I hit enter. It puts in this little guy right here, and it says, you want me to check between here and where? It wants the right boundary now. Now I go just a little bit to the right of it, and I hit enter. And now the other little boundary thing popped up, and it's saying, you want me to find the 0 that's between these two little markers, and you guess means go right on top of it. Close enough. Final answer, it locks in on -11. Do you get how I did that? All right. I'd like you to find the other two numbers yourself. Remember, it's second, calculate the 0. Get to the left of it, get to the right of it. And I'm going to walk around, and I want you to have this one on your calculator when I get there. Okay, leave it on your calculator. That way I'll know that you got there. You can't use trace. Trace is not going to work. Trace gets close, but it doesn't give you for sure 0 value. So second, calculate 0. Yes, I'll show you the window so you can see kind of how to get -20 to 20. And on the y's, I did -300 to +300. And I actually should have probably gone higher, maybe -500 to +500, but doesn't matter that much. I just needed the x-intercepts. All right, I'm going to pause for a second while I walk around and see if you found that correctly. Okay, if you did that correctly, you got 10 as your x-intercept. Raise your hand if you got 10. Okay, good. Then let's move on. That's how you do it with a calculator. Second, calculate the 0. And you got to the left of it, to the right of it, and right on top of it. Okay, now what's left? One more time, we're going to do regression. Remember those regression ones with the calculator? Remember where to find cubic regression? What button are we under for regressions? Stat is correct. Don't blame somebody else. Okay, so regressions are under the stat button. Everybody hit stat. And hit edit. And we're going to put in some numbers. I'm going to give you the numbers that you're going to use on problem 14 on your homework. You're again getting yourself ready to answer this one when I hand this worksheet out. It's got an X and a Y this way. That means this is L1 and this is L2. All right, your X's go across the top. -3 for X is your first one, and then -1, and then 1, and then 3. Okay, and then some more data. The Y is 22. And underneath that, you'd put 25. And underneath that, you would put 12, and then -5. Put in that data on your calculator. Then, once it's in there and you got everything else off of there, if you put them in L1 and L2, you'd go to stat, calculate, cube reg, and don't forget to do after the cube reg, you'll type in L1, comma, L2, comma, Y1, so that it drops it in the Y1. If your Y1 equation, like we were just graphing a second ago, if there's anything in Y1, it's not going to work. You might want to go clear your Y1 equation off so that will work. All right. If you took good notes, you've already done some of your homework, and it's coming right now. If you're having any trouble, especially with the calculator stuff, bring it up. Let me help you. And I guess there's one more thing I'd like to talk about, so I'm not going to stop the video yet. I'm going to do the first problem off the homework with you. Okay, here we go, number 1. f of x equals 3x squared plus 4x minus 4. You're going to want to watch this one because I didn't do much like this. There you go, number 1. Find the zeros algebraically. Well, I know if I graphed it, the zeros would be where it touched. You know, there, and there. That'd be the zeros graphically. But you can't use the graph on this, or you can't use a graphing calculator anyway, on this one. And so what am I supposed to do? Factor it. Very good. Now, how on earth am I supposed to factor that? It's got a squared in it. Oh, that means one of these, right? So then 3x and x, remember this? This is one of those basics that I've been drilling and practicing with you on that top 20 sheet, because factoring is important. It's going to keep coming up. Okay, how do I make a 4? Well, it's either a 4 and a 1 or a 2 and a 2. Which one do you think? 2 and 2? All right, and I'm going to make one of them positive and one of them negative. So I'll just try one and see what happens. I'm going to try this positive, this negative. Outside's -6, positive 2 makes -4x. Whenever you come out with the exact opposite of what you wanted, I got -4x, I wanted positive 4x, then you switch the signs to the opposites. Just the signs. So that plus and that minus gets switched around. That's a plus now, and that's a minus. Now I double check it. Outside's +6, inside's -2. Net result positive 4x. Yay, I did it. I factored it. So now what? Find the zeros. How? Set each of these little things equal to 0. So this guy here, 3x minus 2 has to equal 0. Solve it. 3x equals 2, x equals 2/3. I just couldn't stop myself, sorry. And then this one, x plus 2 equals 0, and then x equals -2. There we go. That's solving them algebraically. Basically, you just have to factor it first. There'll be some that are more tricky to factor. Like number 3. What should you start by factoring out on number 3? Make an x come out first. And then it'll be a quadratic, and you'll have to factor it again. Don't forget on number 34 that there's an x in both of them. Sorry. Number 4. There's a 36 in number 4. Anyway, number 4. You get an x factored out, and then it's x squared minus 36. Do you remember how to factor x squared minus 36? Yes, we've practiced this in that top 20 sheet. X plus 6, x minus 6. So when the x came out first, it looked like that, and then there's an x in front like this. All right, so there's a lot of factoring today.
Oh, wait.
Yes?
For that one, would there be 3 answers?
Yes, because it's an x. If this was just a number, it would not have an answer, but this is an x. So it does have an answer. 1, 2, 3 answers. 6, -6, and 0. Okay, moving on. Let's do number 5 together to make sure you understand what the questions are asking on that kind. Number 5 says state the degree. That's easy. You just have to look at the little powers. -x cubed, and then x minus 2, and then to the 1. If it's not written, you know it's a 1. What's a degree? That's easy. List the zeros and state the multiplicity of each zero and the behavior at each zero. Okay, well, the degree, I just abbreviate it like this. Degree is 3. The roots, 4. 3 plus 1 makes 4. And then the roots are x equals, what's this root? I'll start with the easier one. That one? 2. Okay, the 2 root. What about that root? What's its multiplicity? I'd abbreviate it MPY. Its multiplicity is not 0. What's the multiplicity again? It's the little power. So what's the power for the root of 2? This is the root of 2. That's the power for it. That's the multiplicity for it. 1. Its multiplicity is 1. And then what's the behavior for a 1? Is that a bounce, a cut through, a snake? Those are the 3 words you need. That's a cut through. I'd call it a cut. Good enough. Abbreviating here. What's the next root? The other root is this guy. What root does this have? A 0, because what makes it 0 is what makes it a root. This one made 2 made it 0, so 2 is the root. This one, it's 0 that makes it 0. All right, so x equals 0 is this root, and I'd say the multiplicity, instead of writing out the gigantic word multiplicity, MPY, would be good. Its multiplicity is what? 3, and therefore that's what kind of a root? Snake. That's how you answer questions like 5. And then so 6, 7, and 8 are like that. Find the zeros graphically. We already did number 9. If you paid good attention and you took notes, you have the answers already for number 9. That's the one I walked around and asked you to show me. Okay. And then there's number 10 is just like that. Backside, we got some regression in there. Number 12 is sometimes, it's easy, but you might think it's hard. Just let me come back to your question in 1 second. Number 12, it says, find a cubic with the given roots. In other words, the answers for it, the roots are 3, -4, and 6. If I know it's touching at 3, -4, and 6, and it's a cubic, do you know that can you tell that there's no bounces? If it's got to be cubic, there can't be any bounces, because otherwise it's degree 1, 2, 3, right? And that's got to be it. Except, do we know if it ends going down or up? Nope, we don't know that. Okay, so how am I supposed to write this equation if I don't know if it's going down or up? All we have to do is find a cubic function that has the given roots. So any answer that would go through these 3 spots. So start with y equals to get a function, right? And then how do I get that -4 to come up? X plus 4. How do I get the 3 to come up? X minus 3. And how do I get the 6 to come up? Yep. And would it matter if it was negative in front? Nope. Because both of those, both that and the negative, would just be reversed, but it would go through these points. It would have these roots. So this equation has the roots we want, so it's good enough. Are there other equations that would have worked? Yeah. Mostly if you change this around to have a negative in front. Or you could have a -2 in front. It wouldn't matter as long as it goes through those roots. Yes?
If it's like, you know how like it's a bounce when the multiplicity is a 2?
Perfect. Yes, it's a bounce if the multiplicity is 2. If it's a degree 4, it is also a bounce. Yes. That'll kind of mess with your head, but it's true. Because remember, x squared is a bounce, and x to the 4th is also a bounce. But we don't do much with that. We usually keep it to degree 1, degree 2, or degree 3. Like a snake, a cut through, or a bounce. One of those 3. Yes? It's a good question. How could you get the root to be square root of 3? So if I want, when I add the root that was just going to be 3, I'd go like this, right? How do I get it to be square root of 3? If I wanted the root to be 3, I'd do this. If I want the root to be square root of 3, don't way overthink this. Square root of 3. Because now what would I need to put here to make it equal 0? Square root of 3. So for number 13, that's one part of your answer. Okay, that's all I got for you.